Hello everyone, myself Divya Chaudhary. My project for this semester was AI based assistant chatbot for streamlined university enrollment. So basically, the major idea behind the project was like when we have to get admission or we need to enroll for any university course or any college, we have to go through many sites and read many brochures to get exact data about what is the course structure, what is the fee structure, what all courses are available, and what all courses are we eligible to. So we don't get the data at a consolidated like in a consolidated format or at a one place. So I have made this project so that we can get all the details from a single point, and only we have to upload all the documents at one place. So starting with the project, uh, I have used LangChain. It's an open source framework which help us to build applications using large language models and other AI based technologies. Basically, LangChain is used for processing text to retrieve and to retrieve documents and to get answers to our questions. So it is basically a set of tools that to easily integrate our AI other AI models for text processing and retrieval systems. Then comes embedding model is basically embedding is a layer, we can say, that converts our text into numbers, which are usually floating point numbers in the form of high dimensional vectors. These are called vectors. These vectors capture the semantic meaning of the text and allows us to perform various tasks like semantic search, clustering, etc. So basically, by embedding text into vectors, we can easily compare and retrieve relevant information based on their distance metrics. Distance metrics is like, we can say, if there are two words, dog and a cat, so their distance metrics is very less, while if it is dog and aeroplane you compare, then the distance metrics is very high. Distance metrics means the similarity between the two words. So cat and dog are usually related, so when the models are trained, so they usually get cat and dog as words are like very close to each other, while getting dog and aeroplane is not very close, they are not very close. So this distance matrix is used for prediction, like what will come next and how our text will be processed and how the context of the text will be taken out. So this was the major aim of the project. And basically, for data gathering and pre-processing, I have built a scraper, that is a web scraper, which will scrape the URLs and the websites of the colleges and departments and take out the data. So the data will be processed and then it will be converted to text. For web scraper, I will make another video. So this was my introduction part. Now starting with the code, like what I have done in the code. First are the imports or whatever we have to import for entire code. First is import os. It is a basic library of Python which allows us to work with directory and files. So all the operations that are related to directory and files, like opening directory, closing directory, opening a file, reading a file, then listing all the contents of the directory, so these are all available with import os. Then comes the pypdf loader. So this is used to load the directory and process the pdfs. So basically, there are many other options available with LangChain communities document loaders, like you can have plumber also, plumber loader, where the text, if the text is in table format, not the text format but the table format, then you can use that. Or other options are also available, like camelot or slot or slate, sorry. So camelot is useful useful for CSV and JSON like files. So these are many other options other than PyPDF loader. One another option is unstructured. If there is no proper structure or layout of your documents, then you can use unstructured. Now then comes the text splitter. So basically I have used a recursive character text splitter from LangChain text splitters. So it splits the large document into chunks for improved retrieval. Like I have if I have multiple PDFs, then to tokenize them and to vectorize them, not entire PDF, if it is of large size, it cannot be done at once. So it has to be splitted into parts, and then it has to be converted into vectors. So recursive character text splitter is for that. Then comes in memory vector store. It is used to store and retrieve vectors in the memory. So whatever vectors are created and store, so it the in memory vector store, it retrieves and stores these vectors into the memory. Then comes the sentence transformer. It basically converts the text into embedding, that is text is converted into high dimensional vectors, and these are then retrieved by the in memory vector store. Then is importing list. Since all the data is to be stored into a list, so list and NumPy is used for mathematical or numerical calculations. So now starting with initializing the embedding class model. So first creating the embedding class model. So this class initializes the pre-trained embedding model and provide two functions. So basically the first line of init, that is the constructor, self.model is equal to sentence transformer. It is basically creating an instance of my embedding class and using a pre-trained model. Now the function embed document, it converts a list of text into their corresponding embedding vectors. Embedding, that is vectors. So it is taking a list of documents, then iterating through it, creating for every text it is creating vector, and then all these vectors are combined into a list, and then it is converted. It is the list generated by encode is usually a NumPy array, which is then again converted to Python list by toList method. So the encode method which is used here, it is of the pre-trained model, and it is used to make embeddings or to create vectors. Again, then there is embed query method, which takes the query and converts a single query into vector representation. So the parameter here 0, that means that get the first and the only vector that is present into the list. Now initializing the embedding model. So the model I have used is Alibaba NLP. So it is created, it is a pre-trained model. That means you don't have to train the model, it is already trained, and it was created by Alibaba's NLP, that is natural language processing team. You can use other models as well, like text to text transformer, which is also known as T5 or GPT-4 or GPT-5, BERT, etc. So I have used this model basically because it is powerful and robust, plus it the accuracy is also high. Also it is trained on vast amount of data. GPT-4 and GPT-5 are the largest ones, but we don't need that much big, so I have used this model. Now starting with processing all the PDFs in a directory, there is a function named process PDF directory, which takes a directory path or which is already imported uploaded to the drive. It takes all the documents which are of extension .pdf, so it will process only the PDF. If you have any other extension you want to work with, then it will you can mention the extension here and you can go ahead. So now that document, that PDF is then joined with the directory path, an entire file is located, then file path is located, and then that file is loaded by the PyPDF loader into loader. Now this way the document is pre-processed and aggregates them, so all the documents are pre-processed, loaded by the PDF loader, and a single list of documents is created. Now splitting and indexing documents. This is done by the prepare retriever function, which takes all the documents which were written by the process PDF directory. Now documents are splitted into smaller chunks. Here I have mentioned the chunk size of 1000 and chunk overlap of 200. So basically these chunks are for improving retrieval performance. These chunks are then embedded into vectors and stored in memory vector store for efficient retrieval. So basically since the document size or file size is say very big, and not entire document or file can be read at once, so there are the document is splitted into parts of say 1000 bytes, and there is a chunk overlap. Chunk overlap is basically when we divide any document into parts, there is a possibility that we may tend to lose some data, or there may be some inconsistency. So to overlap that, or to overcome that issue, we have used chunk overlap of 200. Now this text splitter splits it into the chunks, and then these are embedded into vectors and stored in the in-memory vector store. So now going ahead with the first will be the chatbot. Before the chatbot, we'll go with LLM generate. What does this mean? So when we say the chatbot uses the retriever. Now our chatbot uses the retriever to find relevant document based on the query. Whatever query we are giving, say I want the fee structure of so and so college. Now if there is any PDF with named of that college, then it will directly go to that PDF. It will not scan all the PDFs. So the retriever is based on this process. So the chatbot uses the retriever to find relevant document based on the query. The retrieved documents serve as context for answering the query. So that document will be the context where from where the answer will be given. If no relevant context is found, the bot returns a default response, that is, sorry, I don't know the answer. So this is the default response. If suppose all the PDFs or all the documents are related to say colleges and a specific university, and if I asked about any movie or any hospital, so it will not be able to find any context of the given query, and it will return the default response. So for this, there is we have simulated a system LLM response generation, that is LLM generate. So this function simulates an LLM's response using a retrieved context. So whatever context we have used, it will take that and give the response according to LLM. LLM will use that context and give the response. It uses a system prompt to ensure answers are precise and related to the context. Now final how the our chatbot will work. Now the directory path where all the PDFs are stored, it is given in the directory path. All the documents are stored in document. Retriever retrieves all the retrieve all the responses, and now it will give a prompt to give the query, where the user is supposed to type a query, and then user can type a query until and unless user writes exit. It will continue to take a query from the user and give responses. So for this to program or model to work, it has to be made sure that the resources used is T4 GPU, because the models are little heavy, and make sure that T4 GPU is connected and you have a good amount of space and resources. So we can see our chatbot is ready. So now we can type any question or any query that we want. So let's see, what is the establishment date of aerospace department? So the context it has taken the simulated response to. So it is giving established in 1966-67 as the department, and it is given multiple, we can say a large input related to aerospace department. So in this way the chatbot gives answer. We can also give other queries like give details of CSE department. So this is related to CSE departments, and if we have to get courses, give courses of math department. So we can see it has given us the output, and entrance to this program is through JEE Advanced. Students are required to complete basics courses in algebra. So basically the chatbot usually works on the concept of context, where it tries to understand the meaning, the semantics of the language, and usually whatever the similar meaning words are there, it tries to give in return that. We can also ask for faculty members of any other department, physics department. So these are all the faculty members of the physics department: Wolfgang Kame, then Biman Bakchi, and so on. So this was the chatbot, and this chatbot is not only useful for university or admission related use case. It can also be used for other it can be a varied use case if we include uh, other types of file formats. Say if we include files that have tables, so we can use py plumber loader. And because this will work only for plain text PDFs, then we can use other unstructured loaders which will work for any unstructured file which doesn't have a proper format.